Hello viewers, teardown time again. Well, it is always teardown time here on Dexter's Lab. So today we have a Sony SMO-E501 Magneto Optical drive to take a look at. This drive dates from 1992, so it is an impressive 25 years old. It was part of my Quantel haul from last year. It worked for about 20 minutes and then it decided it didn't want to read or write discs anymore. So we can do a permanent teardown on this so we can see inside. Magneto Optical drives arrived in the mid-1980s. In this format, they offered 600 megabytes of rewritable storage onto these 130mm MO discs. The drives use a SCSI or an IDE interface. The MO format has many implementations. One of the most common that people know is the Sony mini disc that arrived in the 1990s for recording music onto. This particular model is of an older design, as in it's a full height 5¼ inch drive for computer use. As the tech matured over the years, the drive shrunk to half height and the capacity increased to 9.2 gigabytes. This one can read and write the original format discs, which are 600 megabytes. The discs are contained in this plastic caddy to protect them. The disc itself is a hard polycarbonate disc, which interestingly is double-sided. So side A, side B. This means the 600 megabytes is spread over both sides, so 300 megabytes per side. This is true for all MO discs like this. Mini disc was only single-sided though. The read-write mechanism is interesting because although these discs encode the data magnetically, they are read and written optically using a laser. Reading the disc is very much how a CD works. A source laser is focused onto the disc and it lands on the encoded ones and zeros. The reflected light changes, is detected and the data read out. This process of reading a magnetic pattern with a laser is called the Magneto Optic Kerr effect, whereby magnetic domains alter how light is reflected. This might be by changing the polarization of the light or simply how much light is reflected back. To write an MO disc, it gets a little bit more complex. To change a bit, the laser power has to be increased enough so that it can heat up the disc medium to the point that it reaches its Curie point. The Curie point is the point where you can actually change its magnetic properties, at which time a separate magnetic coil can change the polarization of the bit, and then the laser is switched off and then the bit is permanently set in the polarization that the magnetic coil was in. Given the magnetic properties of the disc can't be changed unless the actual medium is at its Curie point, it should mean that data retention is very good for MO discs. Though from what I've experienced with mini discs and these drives, the discs seem to outlast the drive mechanics. Yeah, I've had several of these drives fail, and it's not really any use having a data stored really well on a format that you can't read. Anyway, so when we get inside, it'll be interesting to see the laser and the magnetic coil and anything else. Now, I should mention that this drive has no front bezel. There would be a plastic panel that clips on here. This drive was supplied in a Sony enclosure, which meant that the front of the enclosure was the actual bezel. Normally a plastic surround would clip on here if it was to be installed into a PC. So let's just power this up so you can see it load and unload the disc before we take it to pieces. And that's the disc loaded, and if we eject, right, let's crack on with the teardown. So we have a metal cover on the top, held on with some screws there, and we also have one on the bottom as well. So let's just take this off and see where we're at. It's interesting that the warranty void stickers have actually already been opened up. That wasn't me. So it's just a pressed steel plate, and we have a large circuit board with a couple of flat flex cables on the side there running up onto a couple of big connectors there. We have the interface on the back, and that's about all we can see so far. Let's take the bottom one off. Again, nothing really of note on there. There is a plastic sheet on it just to stop any of the circuit boards shorting out on the metal plate. And we are mooned by another large circuit board. So one little interesting feature about Sony products is they always like to give you clues how to take it to pieces. The screws that you need to take out are always the one that have like a double arrow. So there, I think there's one just there as well, and these will be dotted all over the place. Always handy little tip there if you're taking Sony stuff to pieces. Okay, we've got another flat flex there running over to what is on the top of the drive, so that I suspect is going to be the magnetic coil assembly, which actually is the part that changes the actual data on the disc. It's interesting to see here how the this magnetic coil arrangement is actually quite loosely mounted on here. That's obviously to be a bit compliant, so when the disc is inserted in, this will clamp down onto the disc and align itself to the actual disc. And it's also interesting, all of the mechanical little brackets and pressed steel bits. It's very, very typical of sort of this area, Sony design and construction. Lots of mechanical things going on. Obviously we'll see a little bit more once we get a little bit deeper. And one other little detail here, the magnetic coils here are actually the same size as the disc surface itself, so this is not movable. Obviously I said there's a bit of compliance in there, but this does not track with the laser. It covers the entire surface of the disc, so when the laser heats up a single point of the actual disc surface, the magnetic field can be applied to the entire disc. But it's only the bit that's actually heated up to the Curie point which actually changes. So this is a good way to reduce costs. It means this doesn't need to be movable, it doesn't need to track with the laser or anything. It's basically a big sledgehammer to hammer in a very, very tiny nail, as it were. Okay, if we flip this over and have a look at the other side, doesn't seem to be much holding that in. I suspect probably going to have to undo these ones here that have those markers on them, and then this frame should come off. Okay, so we've got quite a bit of stuff going on here. We have this other board with mostly 7.4 series logic on. There's a few other little bits and bobs. Let's just disconnect that off these flat flex cables. We'll have a look at that in a moment. And we've got a number of shielded areas under here and here. Obviously that's going to be the laser and the head. That bit there is obviously movable, so that's the laser head which tracks the disc. We have the main spindle motor, some mechanics presumably for the load and unload, a couple of connectors. Lots of nice little plastic detailing there to allow the flat flex to go around corners nicely, and again there's a little piece of plastic there just to hold the flat flex in place. A nice bit of copper shielding around the flat flex there. And we also have these rubber compliant mounts on the side here, so that mounted to the frame, and that's what mounted into the computer. So there's a bit of shock absorption in there as well. So let's start by removing some of these covers and see what we can find. Okay, there we have the drive motor assembly. I've just ripped the flat flex cable off there. Obviously the motor is actually integrated into the PCB, driver and everything on there, and that is the actual spindle itself. Here we quite clearly have the voice coil that moves the head, and that is actually locked in place. Yes, just down in here there is actually a metal cam which in one position it locks the head so it can't be moved. I think that is actually operated by the disc. When it's actually inserted, it releases this to allow this to move. So when there is no disc inserted, the head is locked in a position. Removing all the big screws, I'm just going to take off these two here which hold down the bar that the system actually slides up and down on, so that should allow me to remove or begin to remove the actual assembly. It looks down, just down in there is another voice coil. So now we can see the die-cast chassis. We have the motor, the spindle there, quite clean on a very nice bearing there. We got a little plastic cover, and then there's some more of the mechanics, and then just through there we have the magnetic coil, which is actually pretty magnetic already. Right, here we have the actual head assembly. We have that, this looks like the voice coil to actually move the head. I suspect this one might just be for feedback. And if we continue to go a bit deeper into this head assembly, let's just try and remove this coil assembly. I think there's a frame that holds the magnets in place. And what looks like a really nice looking neodymium magnet. And there we have the voice coil which drove the head backwards and forwards. Now one thing I've just noticed is these little bearings here that I pointed out earlier, they are actually almost completely frozen up. So I wonder whether that was one of the reasons why it wasn't working properly. Okay, I've just removed as much of the shielding as I can, so there's a whole load of mechanical and electronic stuff going on in here. Really interesting design, how it's all sort of put together. You've got little boards here and flat flex coming over little lumps and going around corners. Really interesting. There's obviously a lot of design gone into that, and here we can see the actual laser lens itself, and of course this, just like a CD, will be on a voice coil, so this will be able to track and follow the surface of the disc to focus the laser into the right spot. So all the electronics on here will be the laser driver, the feedback mechanism to keep the laser in focus on the disc, and of course the main pickup, which actually allows it to read back the reflected light off the disc. So buried away in here somewhere there will be a photo detector and of course the laser diode itself. So what I'm going to do now is just remove all of the screws that I can see, just so we can try and get it to fall apart as much as we can. Now you tend to find in these situations these flat flexes tend to be glued actually onto the metal as well, so I might not be able to get them all off, but we'll see. Yes, just inside there you can see photo detector of some description. Interesting, you can see this is on like a U-shape bracket with a set screw just here. That's obviously to just set for when these things are manufactured. You'll be able to set this up so this is in perfectly the right position. Okay, here we've got the laser lens. Interesting, it's got a voice coil arrangement to allow it to move from side to side there. Back over on this main section there is this PCB here, noting there is a load of little adjustment pots on here just to tweak it. Presumably that's for the laser drive. See if we can, oh, there we go. Right, actually I think that is the actual laser emitter there. That then fires up this way, it's bounced off there, and through this arrangement here it's going to end up going back down, bounced off that mirror, through the lens, and then the reflected light can then come back up and probably be detected by the two sensors that was mounted on here and on here. And I guess I should remove all of these little parts to just be complete. It's just a lens. Another lens. A filter of some sort. Another filter. And we've got another lens in there, and we've got this optical path thing here, which is glued in, so I don't think I'm going to be able to get that out. Got a little mirror arrangement just there, and that is about all she wrote. Got another crystal in the end there. Now, interestingly, on this square crystal thing, I'm not sure whether you're going to pick it up on camera, but one surface is slightly fogged and doesn't look very clear. Maybe that was the reason this didn't work. That the coatings on this filter or whatever it is have degraded. And finally we just need to have a look at this magnetic coil assembly, which actually changed the magnetic polarization of the disc when it was heated up by the laser. So I'm not quite sure how this comes out of here. So there's not really much left in that now, it's just a few mechanical bits to load and unload the actual disc itself, and that's about it. Right, let's have a quick look at this first. So those are the two coils, presumably with some drivers on that side, and we also have this metal bar which was held into this plastic base, And this metal bar was in the centre of that piece of plastic. It is magnetic, and there are a couple of very small bearings attached to the end to allow it to rotate slightly. Not quite sure why you'd need that. Okay, let's have a quick look at the circuit boards. It said this was mostly full of 7.4 series logic, and that is true. There's a custom Sony device there, lots of other little doohickeys and things all over the place. Got a number of power devices there and a hybrid device from Rome, which is labelled R105, that's that bit there, so some hybrid resistor network. And a few passives and transistors on the other side. These are surface mount. Yeah, there is a bit of a mixture between surface mount and through-hole stuff, as was very typical of this era before everything just went completely surface mount. And a look at the other board, which is quite clearly the control board. We have the SCSI interface just here. These two empty slots here would be for the SCSI termination resistors. I'm not quite sure why these are hidden away, that you can't access. It might be that this does actually have active termination that you can actually set with a jumper on the end here, and these are just somewhat redundant. There's some two Fujitsu devices here, 27C256. Those are mask PROMs. Some more custom Sony devices. That looks custom as well, although it is branded NEC, but Sony did do a lot of stuff with NEC back then anyway. We have a WD10C00A. That's probably going to be some kind of SCSI controller. Got a couple of EPROMs there, so presumably holding the firmware for the drive, and a few other devices. We've got some RAM just there and just there, and it looks like we've got power over in the far corner there. And on the flip side, not really much to see, just some passive components and a few transistors. Okay, thanks for watching everybody. I hope you found that interesting. If you liked it, give it a thumbs up. Comments are always welcome in the comment section. Thanks for watching everybody. See you on the next one.